Subscribe now and click on the bell icon to never miss learning from Vedanti.
Okay. Is dv by dt v ka mod is equals to, again, now this is a good question. How to visualize these questions? Now this looks like an advanced problem, and this kind of a question has been seen in the JEE over decades, okay, in some form or the other. V is velocity vector. So what does this mean? When I say velocity is mod, okay, when I talk about the magnitude of velocity, then this is nothing but d by dt is rate of change with respect to time. So this is nothing but rate of change of speed, okay? So if rate of change of speed is 0, what does this mean? Essentially in English language, because this means speed, right? Mod of v means speed, d by dt means rate of change of with respect to time. Rate of change of what? Speed, okay? So what, and when this is 0, when the rate of change is only 0, there is no change, it is 0. So what does this mean? This means constant speed. So again, remember, understand, did you decode this? Did you decode this, students? Did you decode this? It's not hard. Velocity vector does magnitude, only magnitude means speed. Okay, magnitude. Now I'm talking about rate of change of speed. D by dt is rate of change of speed. Now, and when the rate of change of speed is equals to 0, when this is equals to 0, that means it is constant speed, right? When rate is 0, rate of change is 0, so this means constant speed. So basically, now I'm decoding this question. Now it is saying can at constant speed, okay, now let's decode it further. Can at constant speed we have rate of change of velocity. Now this is nothing but a magnitude of change of velocity, right? So this is rate of change of velocity, right? So at constant speed, if a body is moving with constant speed, does it mean, okay, is this possible that a body is moving with constant speed but velocity is changing? Velocity is changing but speed is constant. So basically this is what the question means in English language, right? In English language, right? At rest, if something is at rest, why will, so basically this is not true, right? If something is at rest, then a rate of change of velocity will also be 0, right? It does not make sense. So that means velocity is changing but speed is not changing. Think about it. So again, let me give you an example. If I'm moving on a path like this, okay, understand, if I'm moving on a path like this, right, and I'm moving with a constant speed of 10 meters per second. Here I'm moving with 10 meters per second, and here I'm moving with 10 meters per second. Velocity is changing, see, direction is changing, but speed is constant. Is it possible? Is it possible or not? Yes, it is possible. And one of the classic examples, yes, I think most of you have understood, and one of the classic examples, again, many of you are saying there is no acceleration, then how is it changing? For circular motion, you need acceleration. Understand this. For circular motion, acceleration is needed. But again, we'll get to that later. Now let's have a look. So one classic example is circular motion. Circular motion, or wherever there is a curve. See, you are moving with constant 2, constant. See, like this. But your velocity is direction also. So your velocity is continuously changing. See, here it is 2i cap. Here it became 2j cap. Right? And here it will become minus 2i cap. At 45 degrees, it will become 1 by, what should I say? 2 by root 2. So root 2 I cap plus root 2 j cap at 45 degrees. So again, velocity is constantly changing. It is constantly changing, but your speed is constant. Right? So this is possible, and you can take any one example to prove it. Everyone? Simple? Easy or not? This is interesting, right? All you have to do is visualize and decode. Decode and visualize. Very fun to solve. then how it will be a vector quantity? What will be a vector quantity? What will be a vector quantity? Students, what? Adesh, you are asking now, how will it be a vector quantity? Sir, won't the actual speed be greater than v? No, see. Magnitude of velocity is speed, but the direction is constantly changing. So here, see, you're moving in a car. You're not exceeding your speed limit. You're moving at 10 meters per second. But again, your direction is constantly changing. See, this is the velocity vector. It has changed. It has changed again. It will change here also. Here it will become what? Minus 2j cap. It is constantly changing. Understood, my dear students? Right. So yes, and now comes a very important part. Now someone will say, if the velocity is changing, there is some acceleration, right? If the rate of change of velocity, if the velocity is changing, there is some acceleration. Then the speed should increase, right, with acceleration. Understand this. Now this is a very beautiful thing. I will explain it to you. So if I'm moving with 10 meters per second, right? And if I just want to change the direction and not the speed, so I will apply a force here. Okay, I will apply a force here. Okay, radial force. So this radial force will not increase the speed here. And then what happens at that instant, it will change the velocity vector. After some time, this will move here. Again, I'll apply the same force perpendicularly. If I always apply the force perpendicular to the direction of motion, velocity will not change, direction will change. Just try to visualize it. If something is moving and I'm applying a force like that, always perpendicular to motion. Now the best example is a pendulum. Best example, or for example, if there is a mass here and if I have a string here, tension, and if I give it a velocity perpendicular to like this, so it will continue to move like this, okay, for infinite time. If there is no friction, if there is no air friction, if there is nothing. But again, we'll come to that in circular motion. So students, let's go in the flow. Let's not go too fast here. Okay, just a minute. I think something has stuck. Just a minute, students. I think I'm not able to access anything. Yeah, I'm back. Is everyone able to hear me, see me and everything? Okay. Guys, we will do this later. Till now, just try to visualize it. If you want to change the direction, apply the force in perpendicular. So tension will always act like this and velocity will always be perpendicular, right? So anyways, now let's move on to the next part. So this was the example, right? So which we just discussed. So we understood. Is everyone convinced with this statement? Is everybody convinced with this statement that this is true till eternity, till we are alive, and even after that? Okay? Okay. So guys, let's solve this question. Yogesh, if anybody has any beautiful explanations for these things, please share it on the WhatsApp group. I would love that. Okay? In terms of a audio note or videos, please do that. Let's encourage this. A car covers 30 kilometers in 2 hours. Okay. Now visualize the problem. A car starts from here, and this is the start and this is the end. Okay. So this is the start and this is the end. So it covers 30 kilometers. So 30 kilometers, let's say this is 30 kilometers, and then this is another 40 kilometers. Okay. And so it covers 30 kilometers in 2 hours. So time taken here is 2 hours. And here you are not given the time. Here you are given that you were moving with 20. Velocity is given. For this patch, you are given the velocity. Velocity is 20. Velocity is 20 or speed, kilometers per hour. So you have to find average speed. So what is average speed first, right? Average speed is total distance, right? Total distance upon total time, right? So what is total distance? 30 plus 40. 30 plus 40 is the total distance. 30 is covered in how much time? Okay, total time will be 2 hours plus how much time was taken here. You have to find the time here also, right? So you just have to find 2 hours plus T2. B is correct. Okay, so what is the time? 40 kilometers. 20 kilometers per hour. So 2 hours, right? How did I take out this time? 40 upon velocity, which is 2 hours. So this is also 2 hours. So this will be 70 upon 2 plus 2, which will be 70 by 4, which will be 17.5. 35 by 2. 35 by 2 is 17.5 kilometers per hour. Correct answer. Great. So this is the formal solution for this. And now let's move on to this one. Everybody try to do this. It's a very good problem. Don't underestimate this problem. You will take some time, and I want you to take some time out to solve this question quickly. A particle travels half the distance with velocity v0 and the remaining half with v1 for half the time and v2 for other half of the time. Okay, so everybody start solving this. So a particle travels half the distance. So let's call the entire distance is d. Okay, so this is the entire distance d. So half distance, which is d by 2 distance, and this is also d by 2 distance. Okay, so this is covered half the distance with v0 velocity. Here the velocity was v0. Okay, great. And here for the remaining half, for half the time. Okay, so here for half the time, so let's call this time as t1, and this also as some t by 2. I mean, it's not the total time, it's just for this half the time. Okay, for t by 2 times. So entire time is taken from midpoint to the last is t. So this is t by 2 time. Okay, taken for this. So here it was traveling with v1 for half the time. See, v1 for half the time and v2 for half the time. So this is, everybody familiar with this diagram? Did everybody understand this diagram? Right? Now again, what you have to find, always write that. What is average velocity? Average velocity is net displacement. Okay, total displacement. So distance will be same here, and displacement also, because it's a straight line. So total displacement or distance upon total time. Okay, so total time, let's say that the total time is t. Okay, let's say that the total time is t. Total time is t. Let's call this as d by t. D, capital D by t. Chalo, now let's quickly find what is t. So this is time taken for this will be what? T1, and time taken for this is t. We know that it is t, right? So t1 is equals to what? T1 is equals to d by 2v0. Simple. Distance and velocity are given. Did everyone follow till here? T1 is this. And what is t? T is equals to t1 plus t. T is equals to t1 plus t. T by 2. So t. Right? Now you already know. You know t1, and now you need to find what is t. Okay, you need to find what is t. So how do you find t? Now analyze this portion for finding out the value of t. Come here. So here, what is the equation? Distance is d by 2. So distance covered d1 plus d2 is equals to d by 2. So here, what is the distance covered in t by 2 time? v1 into t by 2 plus v2 into t by 2 is equals to what? D by 2. Distance. This is distance. Another distance, it is equals to d by 2. Okay, from here calculate t and substitute the value there. So from here 2 cancels. So t is equals to v1 plus v2 by d. So t is equals to d upon v1 plus v2. Perfect. Now you have both the values of time. You have t1 also. You have t also. Using some logic, you found it out. Now, final. Whatever we had to find out, let's do it. What is average velocity? Will be equal to total displacement d upon t. T is what? T1 plus t2. So substitute this plus this, which will be equal to d by 2v0 plus d upon v1 plus v2. Now we were not given d. We had taken d, which cancels out. So it is independent of d. Perfect. D gets cancelled out. You can simplify it. Find your answer. Okay. Formal notes have been given to you. So here you first found out the value of TAB. Similarly, you can find out the value for this thing. And let's kind of simplify it only. Let's see what we get. Are we getting the same answer? Let's see if we are getting the same answer. V is equals to under root of, so here multiplication, so this will be 2V naught, है ना? Perfect. So this will be 2V naught into V1 plus V2. So did everybody understand this? Easy, right? It's simple formula. Chalo, great. Now let's move on. Perfect. So this is the solution for that. Now everybody, you have the same big distance which we take as capital D, right? So if you divide it into n parts, 1, 2, 3, 4, 5, blah, 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 and till n, okay? So distance will be d by n, 2. So for this much stretch, V1 velocity, then V2 velocity, then V3, whatever it might be, V3, V4, till here Vn velocity, right? Now what is the V average? If you want to find V average, it is total displacement upon total time, right? D by T, total distance upon total time or displacement. So what is the time here? What is T1 time here? T2 time here? Find T1 kya hai? D by NV1, right? This is equals to D by NV2. Similarly, so basically time will be equal to T1 plus T2 plus Tn, है ना? So each one you can find it out. So it will be D by NV1 plus D by NV2 से लेकर D by NVN, right? So just substitute this value and D will get cancelled. In terms of N and V1, V2, V3, you will get your answer. So D upon, so play with such mathematical things. D by N, let me take it as common. So this will be 1 by V1 plus 1 by V2 plus 1 by Vn. So this and this cancels out. N will go on the top. Let the N go on the top. N goes on the top. And here, when you take the LCM, okay, let's not take the LCM. Okay, because it will be very tedious. So let's just leave our answer like this. V1 plus V2 plus Vn. So this will be your answer of average velocity. Did everyone follow for any generic time? Okay. So Sam wanted to go for this equation. Okay, guys, I think some of you wanted to see this. Quickly, take a picture of this. Take a picture of this. Take a picture of this. Yeah. Okay, I'm going back. Yes, I think this is what we did. And okay, just a minute. Yeah, this is right. This is right because this is 1 by V. We found V. So 1 by V will be this. 1 by V will be this. No need to memorize it. Anytime you get it, do it on the spot. Okay, please don't memorize it. Okay? Chalo. What is acceleration? Like I said, when you press the accelerator in English language, accelerating is increase in speed. In English language, deceleration, decrease of speed. In physics, it is just rate of change of speed. Acceleration, if it is negative, it is deceleration. If it is positive, it is actual English wala acceleration. And it has proper sign. Arithmetically, we have to understand it. And the defined definition is, it is the rate of change of velocity vector. This is a vector. This, by definition, everybody knows. Rate of change of velocity is acceleration, right? Okay, let's move on. So, average acceleration. Now, this is something which we did not do, okay, which we did not do earlier. What is average acceleration? It is defined as the ratio of the change in velocity to the time interval. Now, basically, it is denoted by, average acceleration is denoted like this. So, basically, it is always V2 minus V1 delta V upon delta T upon T2 minus T1. That means if the car is here at place B, from B to C, find the average acceleration. How will you find the average acceleration from B to C? So here it was moving with how much velocity? 4 from B to C. If you want to find average acceleration from CB, okay, C and B, between C and B. So velocity at, final velocity at here will be 12 minus 4 upon, let's say the time here was t is equals to 3 and here the time was equals to, at t is equals to 7 it reached here. Just giving some values. So it will be how much time elapsed? 7 minus 3. So this will be your average acceleration. Did everyone follow? Will be 2. Did everyone follow? Okay. Okay, so basically how it is defined, average acceleration is change in velocity upon the time interval. That is average acceleration. It is usually for a considerable time interval, not instantaneous acceleration. What you already know is instantaneous acceleration, right? Okay, just a minute. Some of you are asking me some doubts. Sir, what is the difference of A? What is the difference of A means? Beta, I didn't understand you, Dheeraj. What is the differentiation of acceleration with respect to time? It is known as a jerk. Okay, again, that is outside the scope of your learning. Okay? Now let's move on. Okay, so instantaneous acceleration, for example, if you're driving a car. So again, obviously all the supercars and the great cars have a acceleration meter also. It tells you how much acceleration you have, right? So at a point, at a particular instant, when your acceleration is varying, you can find the instantaneous acceleration using slope of the curve. How we'll do that? We will see in the upcoming classes. Now let's have a look at this. It's a vector quantity. Unit is meters per second square. Dimensions is LT raised to the power minus 2. M raised to the power 0B. Let's write. Okay. Instantaneous acceleration, as I said, what is instantaneous acceleration is what you've already learned. Instantaneous acceleration is equals to rate of change of velocity vector, right? And it can also be denoted like this. A is equals to V dV by dx or ds, right? Always remember this. dV by ds. A is equals to, remember this also, A is equals to V dV by dx or V dV by ds. How do we derive it? We just multiply dV by dt into ds by ds, and then you take this part and you take this part. So this will be what? dV by ds, and this will, ds by dt will give you velocity, and this will be dV by ds. Okay, so this is also very important. Always remember this in advanced level problems, especially this expression is directly used. Okay. Someone is asking what is RPM. RPM is usually rotations per minute. Again, don't get to that, but again that gives you an idea about the acceleration, okay, in some form or the other. Okay, chalo, let's move on. Okay, so now yes, there is a motor. Perfect. So what does, like I said, decode this. Okay, in physics, especially for the advanced level problems in comprehension, you will find this. Decode this. What is dV by dt? dV by dt is acceleration, right? So what is this? This is the magnitude because the dandas are there. Magnitude of acceleration. And what is acceleration? Magnitude of rate of change of velocity, right? And what is this? Magnitude, no magnitude is there, but it is the rate of change of, this is of, what is this? This is speed. Speed, right? So this is acceleration, this is rate of change of speed. For example, constant speed. Okay, constant speed in a circle. So velocity vector is changing. So there is a change in the. So that means that there is a rate of change of velocity. That means there is some acceleration. But is there a rate of change of speed? No, speed is not changing. Speedometer is there only. So again, this is not changing. So again, you can always visualize. Ramya, what do you mean by? Is it fine now? Is it fine now? Students, am I fine? Are we good to go? Okay. Chalo, quickly. Yes. So what is this? Represents the magnitude of acceleration, rate of change of speed. Now let's have a look at this. Okay. Please focus on the session, not on the video then. Graphs position with respect to time. Okay. Position time graphs. How to find the average and instantaneous velocity from position time graphs. Okay. Let's have a look at this. We'll also have a good understanding of this. Average velocity, my dear students. So this is a position time graph. Average velocity. Okay. So what is average velocity? V average, I said x2 minus x1 upon t2 minus t1. So basically you can just construct this triangle here and find the slope of the chord, not the tangent. Tangent means at a very small instant, because here I'm talking about a bigger duration of time. So this is delta t. In delta t, what is the change in displacement? It is x2 minus x1. So if you see, this length will be x2 minus x1, this will be delta t. So between 2 points, if I have to find the average acceleration, you can just say average velocity is equals to, from a position time graph, rate of change of displacement. So this will be delta x upon delta t. Okay? We will also have a look at some examples. So this is a chord. So this is the, again, you usually don't get average velocity. These are simple questions, but still you might be lucky. So change in displacement is from this point to this point, from t1 and t2 in this duration. Change in position is x2 and x1. So this is the change, that is x2 minus x1, because this length is x2 and this length is x1. So this is x2 minus x1 and this is delta t. Okay. Similarly, okay, students, we have very limited time. I have a session after this also, so please focus. Let's move a little faster now. Okay, position time graph, instantaneous velocity. Again, what is instantaneous velocity? It is the slope of the tangent. Slope at any point will give you an idea about the instantaneous velocity, tan theta, right? If you draw a tangent, if it's a positive slope, you can have an idea it's a positive slope. If you want to be certain, construct it, calculate the angle using a protractor or anything. But again, that's not practical. That is just for you to visualize. So the slope of the tangent at that position, at that instant, will give you an idea about the instantaneous velocity. You know that, right? Because this is nothing but dx by dt. The slope is nothing but dx by dt, is the slope at this point, right? Which is equal to tan theta as well of the tangent. Yes, at a point. Now, examples of position time graphs. Okay, now let's quickly have a look at some examples. First example, everybody solve this quickly. Average velocity from 1 to 3. So initially, this is the duration that I'm talking about. It's a big duration of 2 seconds, right? This is 2 seconds difference, 3 minus 1. And here the initial displacement was 15 and final displacement is 45. So here it is 45 meters displacement, here it was 15 meters. So what is the difference? Difference is what? What is this length? This is 30 meters, right? This length is 30 meters. So what will be the average velocity? Will be this 30 delta x upon delta t, which will be nothing but 30 by 2, which is 15, right? Everyone got 15? No confusion? Chalo. Let's move on to the next part. This is a formal solution. Okay. Everybody, do this. Now, do this yourself. Position time graph. Now, I want to know the instantaneous velocity. Velocity or instantaneous velocity at 3 and 5. So, this is t is equals to 3. At this point, this is the displacement time graph or the position time graph. So, if you draw a tangent, what is the slope? What is the slope at this point? The tangent is making an angle of 30 degrees with the positive x-axis, positive y-axis. So this is theta, right? So at point A, if you analyze at point A, the slope is tan of 30 degrees, because this is making 30 with the positive x-axis. Okay, so what is tan 30? That will be the dx by dt or dy by dt, or velocity at t is equals to 3 will be equal to tan of 30 degrees, which will be 1 by root 3 meters per second, because it's meters and seconds given, right? Similarly, velocity at this point will be velocity will be equal to, yes, d or dy by dt at t is equals to 5, at t is equals to 5, because this is 5, will be equal to tan of just 60 degrees. Tan of 60 degrees, which will be equal to root 3 meters per second. Easy? Good application? Did everyone follow? Right? Yeah. Chalo. One application based question, everyone. Now, so instantaneous velocity is the tan of the angle made by the tangent at that point with the positive x-axis. Okay? Super simple. We've done this in our basic mathematics. Okay? Now again, we'll increase the level in the next class. So please, students, please revise. Don't come without revision in my class next time. Everybody. In which case is the initial velocity or velocity at t is equals to 0. That means velocity here at t is equals to 0, initial velocity, negative, positive or 0. Okay, everybody in the chat, will it be negative in A or positive in A or 0? Negative, positive or 0? Plus, minus or 0? What will it be? Plus, minus or 0? Yes, it will be plus, because look, see, slope is positive. See, slope is positive. See, it's making an angle, acute angle with the positive x-axis. So positive slope. So u is positive. Initial velocity is positive at t is equals to 0. At this point, what is the slope? Oh, it is a negative slope, right? It's a negative slope of the tangent. So theta is acute positive x-axis. Theta is obtuse also. Tan theta will be negative. So this is negative slope, right? Simple visualization. Again here, now this is a good one. There is no slope at all. Angle made is 0. So this is 0 slope. It's flat, right? 0 slope. Draw the tangent at t is equals to 0. So yes, perfect. This is the same thing. D option is the same thing. Yes. Great visualization. That's how you can crack problems in a jiffy. Now let's have a look. So this is the formal solution for the same thing. Initial vector. Okay. So guys, this marks the end of our first kinematics class. I hope you all understood everything. Apart from that, please make space for your assignment also that I've shared with you. Also, have ensure that you have replayed everything from you have 13 sessions, right? I hope you have replayed and reviewed. If you missed any, please watch the replay, and in the next class, promise me, students, it should be a pledge that you will you will not come without preparation. Is it a deal or no deal, students? Is it a deal or not? Deal or no deal? Okay, chalo, awesome.